Azure policy is a core component in Azure governance, complementing identity and access management practices introduced in previous modules. While role-based access control, RBAC, governs who can perform actions, Azure policy specifies the conditions under which resources can be created, updated, or evaluated. This ensures that organizations adhere to compliance standards and organizational best practices. For instance, administrators can enforce tagging rules, allowed resource locations, or specific configurations. By integrating policy with concepts such as intra-ID and built-in roles, administrators create consistent guidelines. This leads to a more robust security posture and provides transparency for auditors and stakeholders. Azure policy uses definitions, assignments, parameters, and initiatives to enact governance at scale. Definitions describe the rules, such as restricting storage SKUs or permissible resource configurations. Assignments apply these definitions to one or more scopes, management groups, subscriptions, or resource groups. Parameters offer flexibility when reusing the same definition across different environments, helping administrators tailor settings to meet varied needs. Initiatives bundle multiple policies into a single unit, making management simpler. When combined, these components enable administrators to encapsulate organizational standards and systematically enforce them, complementing earlier user management topics by extending control beyond permissions to include resource compliance. A policy definition is the fundamental element in Azure policy, specifying resource conditions to allow or prohibit. Administrators can use built-in definitions, maintained by Microsoft, to address common scenarios, such as restricting VM SKUs or requiring multi-factor authentication for administrative roles. Alternatively, custom definitions enable fine-tuning for unique organizational requirements. In the Azure portal, each definition includes a logical rule evaluating resource properties, such as tags or location settings. Administrators can also leverage tools like Azure PowerShell or Azure CLI to manage definitions programmatically. This flexibility promotes standardized compliance, aligning well with previous modules on managing identities effectively. Initiatives group multiple policy definitions into a cohesive set of requirements. By uniting policies under a single name, administrators simplify assignment and reporting across large environments. For example, an initiative might include several definitions enforcing storage encryption, specific naming conventions, and trusted service endpoints. This approach streamlines governance by treating related policies as a single package. Assigning the initiative at subscription or resource group level applies all policies within that initiative at once, reducing oversight and enhancing visibility. This methodology ensures consistent enforcement alongside existing user and group management strategies, elevating the overall governance maturity in an Azure environment. Azure policy assignments define where a policy or initiative takes effect. Scopes range from a management group, covering multiple subscriptions, down to individual resource groups. Administrators can refine these scopes by creating exclusions, effectively carving out exceptions for specific resources or groups. By systematically applying policies at appropriate levels, teams avoid redundant configurations. For example, a globally enforced policy can apply at the management group level, with particular test environments excluded. This aligns with earlier identity-based roles and permissions, ensuring that both role assignments and policies match the hierarchical structure that organizations use for security and resource segmentation. Policy effects define the action Azure policy takes when a resource fails to meet a condition. Common effects include deny, which blocks non-compliant deployments, audit, which logs discrepancies without preventing them, append, which adds defined settings to resources, and deploy if not exists, which initiates remedial action if resources are missing. The choice of effect depends on organizational needs. For new deployments, deny helps maintain strict consistency, whereas audit provides better visibility without disrupting existing resources. Append can enforce tags or configuration properties, while deploy if not exists automates compliance by deploying required modules. These effects provide granular control for varied security or cost objectives. Azure Policy offers a comprehensive dashboard to monitor overall compliance. Once definitions and initiatives are assigned, administrators can track the resource's compliance state in real time. The dashboard highlights how many resources meet or violate each policy. Non-compliant resources can undergo remediation, such as automatic tag assignment or enabling required encryption settings. Additionally, built-in analytics reveal trends over time, pinpointing policy breaches and helping administrators adjust definitions for future requirements. These insights enhance ongoing governance activities, reinforcing the lessons from prior modules on continuous monitoring. The result is a consistent, transparent approach to maintaining security and operational standards. Azure Policy is pivotal for a layered governance model, complementing role-based permissions from previous units. RBAC controls user actions at each scope, while Azure Policy enforces how or under what standards resources are deployed. By combining both, organizations achieve deeper compliance. Only authorized users can create resources, and newly created resources must align with defined rules. Referencing earlier topics, such as external user management or group properties, highlights how policy-based restrictions apply uniformly to all identities. This integrated governance fosters a strategic viewpoint, not only specifying access rights, but also ensuring compliance with corporate, regulatory, or security standards. Azure Policy can address a wide spectrum of requirements, from enforcing cost management measures like restricting certain virtual machine families to improving operational consistency by ensuring all resources have a standard naming format. Teams may also leverage policies to mandate encryption at rest, restrict the creation of public IP addresses, and standardize resource tagging. In addition, advanced scenarios include requiring certain backups or compliance checks before allowing deployments. By introducing these tailored stipulations, organizations strengthen their cloud posture. This complements earlier identity-focused practices, as policy ensures that even properly authorized personnel must operate within the bounds of approved configurations. When implementing Azure Policy, administrators often establish clear naming and tagging conventions to facilitate management at scale. Versioning policies in source control systems, such as Git, helps track modifications and coordinate changes across teams. Testing new definitions in a dedicated subscription or staging environment enables administrators to identify potential disruptions before wide-scale deployment. It is further advisable to combine quick wins like audit policies for valuable insights and gradually progress to deny or deploy if not exist for stricter governance. By closely aligning policy definitions with organizational priorities and referencing prior best practices from identity management, teams can ensure a consistent and secure Azure environment.